Right, we are here and we are looking at Venn diagrams. Venn diagrams are important to us, and we're looking at the three sets A, B, and C. Set A contains the elements 1, 2, 3, 4, 5, 6, 7. B contains the elements 5, 6, 7, 8. C contains the elements 7, 8. Want to find A intersection B intersection C, A union B, A intersection B, A minus B, B minus A, symmetric difference of A and B, symmetric difference of A, B, and C. There are a couple of things that are critical important here for us. But first things first, we analyze the Venn diagrams, but also we look at the fact that the set A consists of the elements 1, 2, 3 up to 7. Okay, so but we need to first look also at the intersection. Right, for example, C consists of the elements 7 and 8, but the elements 7 and 8 are also in B. 7 and 8 are also in B, but 7 and 8 are also in C. So they're in the intersection of A, B, and C, right? And so, moreover, we have that 5, 6, and 7 are in A, are also in B, but 7 is also in C, right? So we have 5, 6, 7 are in A and B specifically, but 7, 8, yeah, in B and C. But 7 is in all of them. It's in A, it's in B, it's in C. Okay, so we have that. But there is 1, 2, 3, 4. So 1, 2, 3, and 4 are in A. So A contains 1, 2, 3, 4, 5, 6, and 7. B contains 5, 6, 7, and 8. And C contains 7 and 8. Okay. So now we continue to analyze this. Right, so what do we get? What do we want right now? We want to solve these problems, and we start. Want to first find A intersection B intersection C. Right, so to find A intersection B intersection C, we already know that this one is 1, 2, 3, 4. This one is 5, 6, 7, and 8. And we want to find A intersection B intersection C where they all overlap. And clearly that intersection consists of the element 7. It's the set that contains the element 7. And this set has a specific name. It's called the singleton. Singleton. Next. A union B. Want to find A union B. But you already know this one is 1, 2, 3, 4. And this one is okay, let's write a bit clearly here and just separate this so that if anybody can just be able to understand. So we have 1, 2, 3, and 4. We have 5, 6, and 7 together with 8, like this. So if we need A union B, right, A union B. A union B now has the elements in A or B of both sets. And now we need to just remember that A has the elements 1, 2, 3, 4, 5, 6, 7, union B with the elements 5, 6, 7, 8. Okay, A union B right now is 1, 2, 3, 4, 5, 6, 7, 8. So A union B now contains all these elements 1, 2, 3, and everything else that is there. Okay, so A union B contains these elements there. Okay, we noted that. Next question. Right. Next question, because we've already found A union B, and now we need to find A intersection B. Right, we've already found A union B, so we find now A intersection B. At this point, we want A intersection B, but we need to fill this here, which is 1, 2, 3, 4, 5, 6, 7, 8. Now you need A intersection B. So A intersection B right now will contain what? The elements that are in both A and B simultaneously. So the elements that in both A and B simultaneously would become the elements what? They are these here. So now A intersection B therefore has the elements 5, 6, and 7. Okay, that is A intersection B. Next, we want to find A minus B, but let us first complete this one. 1, 2, 3, 4, and we have 5, 6, 7, and 8. And we want to find A minus B. Right, so in other words, right now we're saying from A, remove B. If from A you remove B, these can be seen in many ways. You can also see that A intersection B. A intersection B complement is the same as A minus B. Right, so, but from A, if you remove B, you are left with 1, 2, 3, 4. Okay, 1, 2, 3, 4. Like this. Right, so if you have these two sets A and B, and from A you remove B, you are left with 1, 2, 3, 4. But you can also look at it as A intersection B complement, meaning we have A, that is the elements 1, 2, 3, 4, 5, 6, 7. Intersection B complement, which is 5, 6, 7, 8, and that is the complement of B. What is the complement of B? Okay. What is the complement of B? Right, so the complement of B has everything else that is not in B, which means we have 1, 2, 3, 4. Right, 1, 2, 3, 4, and that is the complement. So if you intersect these, you have 1, 2, 3, 4. Right, so the intersection therefore consists of 1, 2, 3, 4. All right, so yeah, that's what we have. That's what we have. Okay, now the couple of things then that are very, very important for us. Okay, so, but obviously we saw that A minus B is the set that has 1, 2, 3, and 4, but also here 1, 2, 3, and 4. Okay, let's look at B minus C. Now, the couple of things that are important. So we have 1, 2, 3, 4. And then we have 5, 6, 7, 8. Right, so at this point then, you have the set B. Okay, so from the set B, you remove A. Right, and obviously if from the set B, this one, you remove A, you're only left with what? 8. Only left with the set that contains the element 8. But you can say, you can use the notation B minus A, B intersection A complement. What is the set B? Okay, we saw from the beginning, at the beginning, that the set B contains the elements 5, 6, 7, 8. Okay, that is the set B intersection A complement. The complement of A has everything else that is not in A, so yeah, we can just put 8 here. And therefore, the intersection of these two sets contains the element 8. So yeah. So we have this exactly. Next, we have B minus A. Right, so now we have the symmetric difference of A and B. Right, so the symmetric difference of A and B consists of the elements 1, 2, 3, 4. And then we have 5, 6, 7, 8. Right, so in the end, then we want to find the symmetric difference of A and B. By definition, the symmetric difference is A minus B union B minus A. Okay, that is the the symmetric difference of the two sets. Okay, so if you have A minus B, and then now you have B minus A. This is B. From B, you remove A. So, yeah. So this is what you're going to have. And this the set that we've shaded, where we're saying from A, remove B. And then you are left with the shaded part. From B, you remove A. Then you're left with the shaded part. So now, which means we're interested in the union. So the union is this or that. So it's going to consist of those elements there. So there are a couple of things, obviously, but we can remember that A minus B, we got it already. Because if from A you remove B, you're left with 1, 2, 3, 4. Right, 1, 2, 3, 4. Just write that one down. So yeah, with 1, 2, 3, 4. That is from A you remove B. If from B you remove A, you're left with 8. Okay, and then now you take the union, which is 1, 2, 3, 4, 8, like this. Okay, that's what we have here. So that is the symmetric difference of A and B. But now, if you look at the symmetric difference of A and B, you can just take the elements that are in the shaded parts of the diagram, of the Venn diagram. So at this point, you have, so yeah, this diagram, once again, we need to remember that is called the Venn. It's called the Venn diagram, okay? So it's a very important diagram. So at this point, the symmetric difference of A and B, therefore, would consist of the elements that are in the shaded parts, 1, 2, 3, and 4, together with 8. Okay, so yeah, just take note of that. Next, we're looking now at the symmetric difference of A, B, and C together. So this is 1, 2, 3, 4, 5, 6, 7, 8. So at this point, then, what then do we have? Right, we actually need to examine what this means. Okay, first and foremost, the symmetric difference itself is, if you write it like this, it is the same as the symmetric difference of B and C, like this. So the symmetric difference itself is what? It's associative. We say it is associative. So it is an associative binary operation. So it is associative. Just write the word associative here. Okay. So we have the word associative. And then now let us find this and evaluate this carefully. Okay. So in other words, the symmetric difference now of B and C, of A, B, and C, we're going to look at it like this. Okay, it is the same as the symmetric difference of A and B. You subtract C from it. Union, the symmetric difference of C minus, the symmetric difference of A and B minus C, union C minus the symmetric difference of A and B. Okay, that's what we write like this. Now, if we take the symmetric difference of A and B, we subtract C from it. Union C minus the symmetric difference of A and B. Okay, first things first. Let's look at the symmetric difference of A and B. We've already seen that. And then we subtract C from it. Okay, so it will be this. Symmetric difference of A and B. With the symmetric, we're subtracting C from it. But union C minus the symmetric difference of A and B. So if you take C and you remove the symmetric difference of A and B, then you're going to have exactly this section here. Right, so if we take C and we remove the symmetric difference of A and B, you're going to be left with this section here. But also, you're going to be left with this section here. Okay, so the question then becomes, what is the result? Okay, let's look at the symmetric difference of A and B minus C. Okay, here the symmetric difference of A and B, which is the shaded part. So we can go up to here. Then we remove C from it. So we're going to be left with what? We're going to be left with 1, 2, 3, 4. We're going to be left with 1, 2, 3, 4. Okay, just take note of that. Union from C, from the set C, remove the symmetric difference of A and B. So we're going to be removing this, you're going to be removing that, and therefore you're going to be left with what? Right, if from C we remove the symmetric difference of A and B, you're going to be actually from C, you're going to remove this part, we're going to be removing this part, but this actually is going to be left out, 7. Okay. And therefore, now this means that you have 1, 2, 3, 4, 7. Okay, so this means that the symmetric difference of A, B, and C, right, which means therefore the symmetric difference of A, B, and C is what? Is 1, 2, 3, 4, 7. Okay, so this is the symmetric difference of A, B, and C all together. Okay, so yeah, we're done with that. So now take note of the things we've done, and yeah, this concludes our discussion on actually the notion of the Venn diagram and the symmetric differences. And so, yeah, we are most certainly very, very excited that we have been able to make much headway. Right. Yeah. So thanks everybody for watching and for joining us, and a very, very goodbye to you.